let's start with some introductions. But first, although I know you're in the right place, because otherwise you couldn't be here, you wouldn't have the password. This is Informatics 550, and that is a survey and ecological data collection tools and data products. This is the first time we've offered this class. It's, I think, a pretty exciting opportunity because we've been working really hard on it. This is the first offering of a class that I think is first of its kind anywhere, although it borrows heavily from great work that other people have done in the past. The intent of this class is to give eco-informaticists a broad introduction to the institutions, organizations, research observatories, sensor systems, APIs, and data products that are most commonly used and most broadly applied in our field. There's an emphasis on the United States, although we are going to touch a little bit on global infrastructures and informatics, but that's okay because this is a US focused audience here. So this class is intended for graduate students. It's intended for computer science graduate students or informatics graduate students who are very interested in ecology and environmental science. Because of that, it has a fairly high expectation in terms of the background that's required for your programming capabilities, your savvy with data, and with just computing in general. So this is not the class to be in if you don't have a background in that stuff. We do have some material to try and give yourself a self-test for where you're at, and also do a little bit of makeup work. It's not much, but there's a little bit of pre-work that's mentioned in the BB Learn shell, and that should have been mentioned in the email that went out to everybody as well. Work your way through that today if you're not sure where you're at, and that'll give you a sense of whether you're ready or not. I want to start by introducing my co-instructor, Kate Duffy. Some of you know her already.
Hi. Yeah, and I was just about to type. Also, you can find if you want to sort of brush up on some of those skills and make sure that you feel comfortable, the first chapter of the textbook that Ben sent out has a lot of links to help you just brush off some cobwebs and things like that. But yeah, I'm really excited to see all your faces. We've been working really hard on the textbook. I'm essentially the sort of back-end person building out the textbook and working with all these organizations to build out the exercises. So if you ever have coding questions or things like that, we'll talk about that a little bit more at the end, but I'll be the person to sort of reach out to about those things.
Kate's been doing the hard work for the last couple months, putting together our online textbook, and she's been the lead author on that. So thank you very much, Kate, for that work. This course is, it is the brainchild of the entire team of faculty who are running the Eco-Informatics program, and especially the leadership of the T3 National Research Traineeship Program. This is one of the anchor courses for that program. So we, when we were thinking about what students needed, or what we thought students needed to launch a successful career in this area, this is one of the courses that we decided was necessary. So we invented this course. And so I hope you really like it. We're putting a lot of work into it. And if it's successful with your help and with your feedback, it's a course that we want to publish as an online textbook. It's something that we're going to be trying to offer nationwide in terms of being a resource that other faculty and other students around the world and around the country that they can take. So this course is not just it's not just an NAU course. It's also it is an innovative effort to pilot this mode of PhD and graduate education in this area. And hopefully that will be really successful. So a little bit of orientation to the format first. The format is centered on It's NAU Flex. You've read about NAU Flex. Basically, right now, NAU Flex is an online synchronous video course. Hopefully, at some point in the semester, intentionally sometime in September, but maybe later, we will switch to the in-person format if we want to. It's optional for you as students, and if nobody wants to come in person, then we'll keep doing it this way. But if you want to do it in person, after that in-person date passes, then we'll have a small group meeting in person and the rest online. And we'll be using this link. This is Kate's link, so she's in charge of running it and also recording lectures. Have you started recording, Kate?
I have, yeah.
Okay, so per NAU policy, we're recording all lectures as a part of this NAU Flex course. You should already know that that's happening in all your courses. If you don't, now you know. It's being recorded. These lecture recordings are for our use only. They're not, we are not going to post them publicly, and we ask that you do not do that either. Because it's very different legally to post recordings publicly versus posting them for the private use of those who are participating under NAU governance. Those will be available on the BB Learn site. So BB Learn site. Let me share my screen. Oh, Kate, you need to let me share my screen. So go to your BB Learn if you haven't already. That's where at least some of the content's going to be, a little bit like the syllabus. So BB Learn. All right. BB Learn. So if you want to get to BB Learn, this is Blackboard, the notorious, infamous, famous Blackboard system for online learning. You're going to log in. It's access only. You have to have any login credentials to get into the course, right? So go in there, and you're going to get in to your BB Learn interface. It's going to tell you about all your trainings and all your courses that you've been signed up for. You're going to click on this one. You should see something kind of like this, although it's actually going to look a little different for everybody, depending on your settings, and instructors have it look different too. So look at syllabus and schedule. You have access to the syllabus. There's a working schedule here. The working schedule is an Excel file. Wait, no, that's a Google Doc. So this working schedule is going to change as the semester evolves. We're going to tweak it. The schedule in the syllabus is provisional, and hopefully we'll stick pretty closely to it, but there's no way to ever stick exactly to a schedule. The anchor for the course is actually not the BB Learn site. BB Learn is going to be how you'll turn in your assignments and look at your grades, but that's the only functionality we're running through BB Learn. I like it a lot more as an instructor, not to work inside the clunky BB Learn interface. So we've got a GitHub textbook. Oops. So Scooter, I saw you say something about this.
I have an updated syllabus that should have been uploaded, but it looks like some of that stuff didn't quite load. I've dropped the links here in the chat so you guys can access the textbook.
All right, thanks. I must have been talking when that happened. There we go. The textbook. Yeah, so using the correct links, there you'll get to the repository, and GitHub is as close to a universal best practice as there is now in coding. And so we're going to be using it, including for the textbook. If you find problems with the textbook, you're going to push them as bug reports up to the Git, and the Git has compiled a digital textbook. The book that we've been working on, Kate and I, is it's somewhere between a really big lab manual and a textbook. So it's not voluminous and wordy the way a textbook is. It's pretty lean and it's pretty step by step. But it is actually a textbook. It's not just a lab manual. It contains your exercises and assignments. It contains links to readings. And we're basically going to go through this whole textbook, line by line, the whole thing. It's also going to be our lecture notes. So you're going to want to open it up and follow along. You may want to open it before we do our lecture that's scheduled. There's no reason you have to wait for us to go through it. But we're going to go through this section by section, line by line. We're going to talk it through together. And that's basically how we're going to run the course. There's office hours too. Office hours as listed in the syllabus, they're going to be at 10 a.m. to noon on Tuesdays. If you're in the unlucky situation where you have every minute from 10 a.m. to noon on Tuesdays booked all semester for other classes, let us know and we'll try and accommodate you. We're going to do video office hours, and I suspect that's mostly going to be technical Q&A with Kate, although I'm going to be there as well. So we can talk about whatever you need to during the office hours. Of course, as appropriate, please feel free to ask questions during class. So there's two good ways to do that. One is to put your hand up in Zoom, and the other is to type a question into the chat box. A great way to use the chat box is actually for questions, because then we can answer them at an appropriate moment. Put your hand up, put the question into the chat box. What you shouldn't do though is carry on a side conversation in the chat box. We want to have the conversation focused here in the main room. So don't go off in tangents in the chat box. If you see a question in the chat box and you're sure you know the answer to it, feel free to answer it in the chat box. You don't need to wait for the instructor to jump in and answer it. That's a good thing to do. We also have a discussion forum on the BB Learn, which we can use. I encourage us to use it. Students don't always use it. We'll see how it goes. Sometimes it becomes real popular, sometimes not. But I encourage you to use that discussion forum to pose questions, and so that we can all answer them together. It's usually better than having emails flying around. Back to the syllabus. You should be able to see this. Learning outcomes. We want you to be able to identify the major ecological and environmental data organizations, or some of them, and their tools and their missions. We want you to be able to summarize and understand the function and the advantages and pros and cons of major ecoinformatics tools like APIs, metadata standards, repositories, etc. We want you to be able to apply the main toolkits and data workflows of several different ecoinformatics organizations to get data, produce some simple research results, and answer quantitative questions. We want you to understand career paths in this area. So we want you to know how you could get involved in ecoinformatics work in your career with these organizations, and also how you could build a PhD or thesis program or research program that partners with these organizations as a part of your relationship with your lab and your advisor. So we want you to know how to plug in. You're going to have a chance to network a little bit with people who do ecoinformatics with major organizations. And we want you to start thinking about and be able to articulate research questions about using integrated ecological and environmental data. So we're gonna be pushing you to actually articulate some of those questions. We want you to be able to identify and use the most appropriate tools. That's kind of like one of the earlier outcomes. And there's going to be a little bit of literature as it is. A lot of the literature in this area is documentation. A lot of it's manuals, a lot of it's websites. But there is also some some writing in this field as well of ecoinformatics. And so we want you to be familiar with those papers. Grading. My goal as an instructor in a graduate course is to aim for a real medium sort of level of difficulty. You know, this is a core course for our PhD program, and so it is not easy, but we're trying to calibrate it so that it is not going to be a huge use of your time either. We want it to be pretty normal in terms of workload expectations, which is to say roughly 9 hours a week, although that'll go up and down a bit. You have to attend, and that's pass-fail criterion. I'm not keeping attendance, but I do notice in a class this small if there's a pattern. Homework, quizzes, and assignments, anything that's small and that's not labeled as a major lab assignment or project assignment. However many of those we do, we're going to weight them all equally into 40% of the grade. Same story for our coding lab. So every chapter or unit is going to have an API-based or coding-based assignment. Those are like a lab activities. Those will all be equally weighted into 40%. Don't be deceived there though, because probably the coding labs are going to be they're a lot of work compared to some of the other things, and they're only 40% of the grade. So when we give you a reading or a simple presentation assignment or something, don't skimp on that just because it's small. It might actually be worth more grade than the coding labs because of the way this is balanced out. In the final presentation, that's going to be, we're going to get to that, but the final presentation is has to do with you working out a research question and doing some preliminary work on it using these tools. And so it's kind of like a final project. It's not going to be a ton of work, but that final presentation aspirationally, or that project, is meant to be a seed for your work in partnership with these ecoinformatics organizations and or your thesis work, right? So we actually want you to pick topics to work on for your final presentation that are leading directly into your PhD track, your thesis track, or an internship with one of these organizations next summer. So we're actively encouraging that while not requiring it. Does anyone have questions about NAU Flex before we get into the schedule? NAU Flex is simpler than it seems. Any hands up? I'm looking for hands up. I don't see any hands up. Yeah, NAU Flex is easy. This is NAU Flex. It's just not as complicated as it sounds. We're not having a lot of trouble with this in the informatics school. Some departments are having more trouble. We see it seems to be pretty smooth sailing for us because faculty and students are already pretty savvy with this stuff. Okay, back to the syllabus. Class outline. So we've broken this up into weeks. There's roughly 16 weeks. Of course, this semester it's slightly compressed. And exam week will be a little weird, but we're going to be done by Thanksgiving. That's the plan. And so it's broken up into units, and some of those units clump together into blocks like phenology, neon, remote sensing from satellites, remote sensing from airborne or near service, and also relating point sensors to gridded information. So those are major themes. But as we move through this, the observatories and research infrastructures and institutions that we're gonna be working with actually form the progression and the background from the course. So I'm gonna start with neon, which is really the 800-pound gorilla right now. Neon is the newest, but also probably the most central of these research infrastructures in ecological and environmental informatics in the United States. And so we're going to spend the most time on NEON. And we're going to anchor the course with NEON's tools. So we're going to be working on bringing other infrastructures data in so it can be interoperable with what NEON is doing. That's going to be a main theme. Not that you can't leave NEON out. You can, of course, do things without NEON data, but for efficiency in this course, we're using it as a focal point. Also, NEON leadership and scientists are directly involved in this course. The director of NEON and the strategic VP of NEON have both personally joined several calls and are investing staff time in supporting this course. They're very interested in seeing how this works. They're very interested to meet you, and I hope we're going to be able to get to do that. And then there's NEON staff who are going to be showing up in the course and helping us. We're going to go through the terrestrial observation system, which is NEON's like core site-based sampling sensor system. We're going to look at the National Phenology Network, which is based out of Tucson and the University of Arizona. They, of course, are related to NEON in some ways because both deal with phenology, among other things. Then PhenoCam, continuing the theme. PhenoCam is led by Dr. Andrew Richardson, but is also a global network and relationships with National Phenology Network and NEON. And PhenoCam actually runs the NEON camera systems. And Kate has a lot of experience working with those. So in there, we're going to get into image processing a little bit in cameras, which is pretty cool. That's an important and growing technique, is just taking pictures of stuff and then extracting the info you need. Then airborne. That is near surface remote sensing. So NEON airborne observation platform and hyperspectral imagery. That's going to give you training that's useful for airborne, but also for drones. Although drones tend to be a little more boutique, UAVs, right? So there's hyperspectral, there's LiDAR, there's DEM. Then we're going to get into the big remote sensing, NASA's Earth Observing System, which is the main, although not by any means the only Earth observing remote sensing platform. There are dozens of satellites involved in NASA's Earth Observing System. We're going to learn how to use that data, about using NASA's DAACs, about that whole system of satellites and how to make use of all that stuff. LPDAAC is going to be our partner on that. And we're going to be using their APIs. MODIS, you've almost certainly seen MODIS around. You know, MODIS is probably the biggie for NASA EOS. It's their main imaging system, which is the basis for all kinds of things. Then the USGS. We're going to get into the aquatic side a little bit, just a little bit. So the USGS has the main mission in the United States of doing monitoring of stream flows and of the hydrology of the nation, the measurement that is. And so there's a lot of hydrology data with the National Water Information System. And then we're going to tie in a little bit to aquatic data that NEON collects. Of course, there's also lots of other aquatic data. We're not going to get into EPA or state level aquatic data because there's dozens of different platforms there and we just don't have time, but they're there too. NOAA Physical Science Laboratory. So we're going to get into gridded climate data and gridded data products, which are the way that we communicate a lot of our climate model results and store climate model data. It's also how we store observations, gridded climate observations. And so this problem of relating gridded data to point sensors is a major theme. It's a major methodological issue, and we're going to touch on that there. We're going to look at North American Regional Reanalysis and also PRISM gridded data products, which are two of the main ones that gets used, not the only by any means. but being able to be familiar with those will help you with many a research project. Finally, CMIP, which is the big the big climate modeling platform, CMIP. CMIP 5 and 6. I've mostly worked with 5 in my career, but 6 is now coming at us. And so we're going to end there. That's the arc of the course as we conceived it. I'd really like to know from all of you, perhaps by email to Kate and I, whether you think anything really important is missing for your purposes. Of course, there's a lot of stuff missing, and we can't stuff really any more into a 1-semester course. But we'd really like to know from you whether there's specific organizations or specific data platforms or observational platforms that you would really like to see included in the class. That would be really helpful for us. And you can tell us that now if you want, or later, either way. We've got some course policies. We've got some COVID policies. They're there. University boilerplate academic policy statements. Go ahead and read them if you haven't already. I expect that with this group of graduate students, we're not going to have any issues with this stuff, and that you've already been around this merry-go-round many times. So I won't read it to you. But if you have any questions, let us know. Particularly about COVID. There's a lot of questions about that. All right, let me pause. I've been talking a lot. I've been talking for half an hour. Are there any questions about that boilerplate before I get into introducing the class and our first chapter of the textbook? All right, let's do some introductions. I'll start. So I'm Ben Ruddle. I'm the director of the School of Informatics, Computing and Cyber Systems. I'm also a professor in that school. I was an informaticist before it had a name. When I was a master's student, I wrote a good portion of the book titled Hydroinformatics, which was, in that area, the first publication that had that name on it. I did master's work on the hydrologic information system, which still exists and is run by KUASI. That's the University Hydrology Society, KUASI, which provides access to water data. Did my PhD at the University of Illinois in Urbana-Champaign in information theory. So that's applications of formal information theory. That's the computer science and Shannon information, Kolmogorov, bit length, code length stuff. And we were applying that to that theory to models and observations from climate and hydrology systems to try and understand information content was coming out of research platforms. I contributed to the design of what is now the Intensively Managed Landscapes Critical Zone Observatory in Illinois while I was a student. And so early on, I was really, when I was in your position, I was contributing to observatory design, sensor platform design, measuring information content, and a lot of data integration. We just kept saying, man, we're spending like 95% of our time on trying to figure out how to put data together. Actually doing the research is so easy after you do that. And we just didn't have very good tools. We weren't very good at programming. We weren't very good at using software systems. The APIs and the languages were all really primitive, pretty narrow. There weren't a lot of community developed open source libraries for things. So it was just like pulling teeth every time you want to do this. Esri hadn't figured out how to read NASA data. That was impossible at that time. You needed special software packages. So we're just spending a lot of time on informatics when I was a student. And things have come so far. It's now becoming its own field, and a really important field, right? And I have an interesting background, I guess, from degrees point of view. So we used to come out of just random degree programs, but we were doing informatics. But where we came from was some disciplinary specialty, right? So there weren't like computer science informatics programs or eco-informatics programs. It was, in my case, a civil engineering program. And I was a civil engineering water resources program. So I'm a civil engineer, I'm a hydrologist, but really I'm an informaticist. The research that I do right now is focused on, it's mostly informatics stuff. We're mapping the nation's supply chains and doing a lot of systems resilience, network resilience, and visualization work with the Fusion project. We are also building a data system to directly attack the lack of primary information about flooding in cities, in and around cities. That's the FloodAware project. FloodAware is a close cousin of Andrew Richardson's PhenoCam network. It uses the same hardware, actually, and very similar techniques, although it has a much more of an emphasis on communicating emergency information or real-time communication to users rather than the more scientific focus of PhenoCam. And I do stuff like that. So if you're interested in any of those things, I'd love to talk to you about it. Let's see, I've been at NAU for 4 years. I was at Arizona State University on the engineering faculty for 9 years before that. And I really love living in Flagstaff. This is my favorite place to live. It's my favorite group of faculty that I've ever worked with. And it's just a great place, I think, to live and to study. So I'm really happy that I'm here. I'll stop there and move on. Kate, would you go next, please? And don't take as long as I did.
Yeah,
I'm sorry, I was being a little selfish there.
I'll be brief, yeah. So I'm Catherine Duffy or Kate Duffy, or you can call me anything that starts with K. I have a PhD from NAU in Earth Science, Climate, and Landscape Change. And then I ended up spending the next 2 years working in Andrew Richardson's PhenoCam lab as an open source software engineer, and working with me on data a lot as PhenoCam processes all the imagery, as Ben was mentioning. So sort of built my chops in open source software engineering, and I'm very passionate about open data, open code, open repositories. And so that's why I'm here helping create all these materials for you guys. And I'm really stoked that you're all taking the class. Thanks.